All right, guys. So it's 2:30, so we're going to get our program started. So welcome, everyone. My name is Jamie Thompson. I am a marine biologist and ocean educator here at the National History Museum, National Natural History Museum. And we are going to talk today live to some scientists that are in the Gulf of Mexico doing some restoration work. So to give us a little background on the kind of work that they are doing right now in the Gulf of Mexico, we're going to talk a little bit about the ecosystems that they're looking at. So I've got a quick video here for them to take a look at. So this is a deep sea coral reef in the Gulf of Mexico. So the deep sea is the biggest habitat on Earth, and it is home to a lot of really vibrant and diverse ecosystems. So once you pass below about 150 feet in the Gulf of Mexico, you get to the deep bottom or the deep coral reef systems, and they're home to a lot of vibrant life. So you can see these pink corals and these sponges and different invertebrates and fish that are swimming around. And these ecosystems are really remote. They're several miles offshore, but we can still impact them through our activities. So in 2010, the Deepwater Horizon oil spill happened, and 770 square miles of deep sea habitat was impacted. So here you can see these are deep sea coral reefs that have some oil on them that has been mixed with dead plant and animal material, and it's covering these corals. And so to restore these ecosystems that were damaged, impacted by the spill, we are doing a couple different restoration projects. They involve mapping the seafloor, and using ROVs like you see on screen, and this AUV, an autonomous underwater vehicle. And they involve also growing corals, deep sea corals, in aquaria, like you see here. This is the species of deep sea coral that we're growing in one of our labs. And they also involve monitoring different threats and like invasive species, like you see here, to these ecosystems. So we're going to talk to some scientists working on this restoration project on the Nancy Foster, which you just saw a picture of. It is 187 feet long. It has 36 berths. Do you guys know what a berth is on a ship? Any guesses? It's a bed. It's where people sleep. So it has 36 beds on the ship. So we are going to talk to our scientists that are on board. So first, we're going to tell you how to do the questions. So our friends Alia and Bailey, they're other ocean educators here. They are in the fabulous tan jack vests, and they are going to pass out some sticky notes for you to write your questions on. So if you think of a question, you can write it on the sticky note, and you can hold it up in the air, and one of our ocean educators will come grab it, and they will have it put up on the wall so that I can ask the scientists on the vessel. So while you guys think of questions and get your sticky notes, we're going to introduce our scientists. So first, we're going to talk to Karina, who's located on the inside of the ship. So Karina, tell us about yourself and what you do on the ship.
Hi, everybody. I'm located in the dry lab of the Nancy Foster. My specialty and my role here on the ship is seafloor mapping. So I'm supporting seafloor mapping operations while we're out here. We have a multi-beam sonar on board that we're using to paint the seafloor with sound. So as you can see down below, the ship puts out a swath of sound that then is received back. And from that, we can kind of interpolate seafloor, the depth of the water, and some other things that inform habitat maps. So that's what my role is here, and that's what we're monitoring back there on all those computer screens.
That's so cool. So now we're gonna move to the outside of the ship, and we're gonna talk to the project manager of the ship and the scientific lead for the ship, Charlie. So we are gonna move to the back of the ship with our mobile camera. So we are moving throughout the ship right now. We're moving from the dry lab inside the ship where they do the floor mapping, and we are moving to the back deck. So in the corner, you can see our back deck camera. That's a live look. And here is the big giant. This is my favorite part where they go from the inside to the outside. And they have to turn this massive wheel. How many weeks outside on the ship? So we are moving to the outside of the Nancy Foster. And here you can see the Gulf of Mexico. The beautiful Gulf of Mexico looks pretty calm today. Hope no one's getting seasick. And we are going to talk to Charlie. So why don't you tell us a little bit about yourself and what you do here on the Nancy Foster?
Hi, everyone. Charlie Menza. I'm a spatial ecologist with NOAA at the National Centers for Coastal Ocean Science. I typically sit behind the desk in Silver Spring, Maryland, but today I am on the RV Nancy Foster in the middle of the northern Gulf of Mexico. We're about 100 miles south of Pascagoula, Mississippi. And my job today and for this expedition is chief scientist. So I help coordinate all the different scientific operations. We have an autonomous underwater vehicle like the one you saw earlier. We have CTD casts that are probes that we send in the water to measure conductivity, temperature, and depth. And we have the multi-beam echo sounder. So my job is just trying to figure out when all those things are going to be used and where they're going to go. Thank you.
So cool. So we've heard a lot about seafloor mapping. And either one of you can answer this question, but why would you need to map the seafloor? Have we made all the maps that there are? Why are we still mapping?
So we want to map the seafloor for this project because we want to document the abundance and distribution of special communities. In our case, we're looking for mesophotic and deep benthic communities, particularly hard bottom sites that harbor corals and fish and invertebrates. These are really important. They are places where fish congregate, they shelter fish, provide habitat, provide food, and they're very diverse. So there are special places in this world, and we still are learning about them. So our job here is to find out where they are and then to figure out how they're doing.
All right, I have a question for Karina now. I've got a question that says, what are you guys looking at on all those computers? So you've got a lot of computers behind you. What are they showing us?
Yeah, so we have a couple of computers. Well, the suite of 6 computers back here give us some real-time information about what the sonar is doing. And that's also where we communicate with the bridge where the ship drivers are. So we've come up with our plan of where we want to go, what we want to survey. We create that down here on these computers in the middle, and then we send that up to the bridge, or they have a repeater up there, and then they'll navigate our way to that. And then once we start logging sonar data, we'll see it on this screen down here. And then a bunch of the network of computers and everything is connected. So then we pull the raw data up over here and process the seafloor surface and then create some images from that.
So I got a couple different questions from people, and they want to know how both of you, how you guys were able to work, how you guys are able to work on a ship, and how do you get into this kind of a career? So it sounds like they maybe want to get on a ship one day.
So as a marine biologist, if you want to work at sea, you're probably going to get on a ship. Working at NOAA offers that experience in many different ways. Both Karina and I come at it from slightly different angles. So I joined about 20 years ago, right out of college. I took a job as a statistician, and then decided I really need to see what it is I am analyzing. And so my boss had me go out, and I started as a NOAA scientific diver, surveying coral reef fishes. And 20 years later, I'm on the Nancy Foster looking at deep water communities, and super happy. This is an exciting career.
Awesome. Karina, how did you get to where you are?
Sure. So as you can see, I'm wearing uniform, and and Charlie is not. So my career path looks a little bit different. I am an officer in the NOAA Corps, which means that I continuously rotate through assignments every 2 to 3 years within NOAA, with a primary focus on ship driving and navigation. So I did 2.5 years on a hydrographic ship, which serves to update nautical charts and do sonars of the sea, mapping of the seafloor like we're doing, but for a different purpose. And then I rotated into a land assignment with the National Center for Coastal and Ocean Science. And that's how I got my foundation in seafloor mapping, and then am now using it for scientific and conservation purposes. Yeah, so NOAA Corps officers exist to primarily drive NOAA research vessels. We'll do 2 years at sea, 3 years on land, and then we go back out for 2 years at sea, and our career kind of progresses that way.
Awesome. And just a reminder to our audience, if you've got a question written down, you can hold it up. But if you have a question and you're out of sticky notes, you can raise your hand and someone will come bring you a new one. So I've got another question. I've got this several different times, and that's how long are you guys normally out at sea?
This leg is about 2 weeks, which is pretty typical for the Nancy Foster, about 10 to 15 days underway. Some NOAA ships can do up to 20 or 30 days even. So for this ship, we're operating in a very average range of about 2 weeks, but sometimes you can go out longer.
Awesome. So what might make you have to return back to shore? Like, you can't stay out there forever. Why do you have to go back?
Well, all of the ships have very different operating restrictions. Sometimes it's how stable you are in the water. You have to adjust the weight of the ship. Sometimes it's something as simple as we don't have enough food. And then, as Charlie might be able to talk on a little bit more, sometimes it's weather based, and if the conditions out in the water are safe for operating.
I can expand on that for the weather. So we're on day 3 of a 2-week mission, and it's likely that we're heading back to port tonight, unplanned because of the weather. Right now we have super calm seas, and you wouldn't think this was going to happen, but 24 hours from now, it's going to be 8-foot swells. Pretty dangerous to be out here, and definitely uncomfortable. If the waves get too high, at some point you can't collect good data, and so we'll be heading back in, keep everyone safe, and try to head back out when the weather calms down.
Wow, that sounds dramatic. I have a question from Sydney, and she asked, "What is your favorite ocean animal?"
Personally, I like whales. They're huge. They're
Reaction from our audience. That got a big reaction from our audience. They love whales too. Karina, do you have a favorite ocean animal?
I think I'm gonna have to go with jellyfish. Ooh. I think they just look really cool, and they can be all kinds of sizes and have all kinds of cool abilities. So
I think if it's possible, our audience may have reacted bigger to the jellyfish. Sorry, Charlie. Okay, so I have a couple different questions about the oil spill. So one of them is, why was oil from the spill able to go under the sea?
Well, the oil started under the sea. It was underground, and they dig wells to get it out, and then they pump it to the rigs, and then or they pump it to land. The Deepwater Horizon event, there was an explosion on the rig. The well started leaking, and the oil was distributed different places in the water column. My understanding is, they tried to mitigate the impacts, and some of those mitigation strategies had collateral impacts, like keeping some of the oil in the water.
And then I have another question from Sophie about the same oil spill. And did the oil spill move to different parts of the world? Or did it move to different parts of the Gulf of Mexico?
It had a very broad geographic distribution of impacts. My understanding, though, is that it was, yeah, if you look at the map that they're showing now, it was about the footprint of the size of Virginia, and affected 5 different states.
So you guys, Charlie said you guys are going to have to head back to port because of a storm that's headed. I got a question about how fast does the boat go? So if a storm was coming in, you really had to book it. How fast could you get there? Karina, you might know the answer to this.
Yeah, the ship typically transit at about 10 knots, which is, I mean, relatively close to miles per hour, give or take a couple miles per hour. And it'll take us about 12 hours to get back to port from where we are now.
Wow. All right, so we're coming to the end of our program. Audience, if you have any other questions, you can stick around and maybe I can answer them. But let's give both of our scientists a round of applause for being here with us.
Thank you.
Thanks so much for being here. I hope that the trip isn't cut too short by the bad weather, but it doesn't sound great. And I hope that you don't get you have safe seas on your travel back. All right, bye guys.
Thank you.
Thank you.
Bye.
All right, thanks everybody. If you have any other questions, me or maybe one of the other ocean educators can wait. You can watch the camera, go back to the ship, and see what's going on. Okay, so they were studying deep coral. Did you know the coral? Yeah, you have to see the coral thing out over there. Check it out. There are corals that are deeper in the ocean too. So this